Hello, my name is Dylan and welcome to this third lesson on the Introduction to Functions. Today we're going to investigate the patterns that are formed when we use formulae. By the end of this lesson, you should be able to recognize and describe a numeric pattern that is formed and use this pattern to predict output values. If you want to plan how much money you will make, you need to predict the effect that certain factors will have on the amount of money that you make. Two of these factors are the amount of money that you are paid and your fixed costs or expenses. Now, in the first lesson, we did a very simple example. And do you remember the pattern we saw as we filled values into a table? When the mass increased by 1 kilogram, we repeatedly added 6,5 to calculate the amount paid. To plan effectively, you need to establish whether or not a pattern exists. If a pattern does exist, then you can predict the effect on the input value. And remember, the output value depends on the input value. Remember also what we did in lesson 2. We introduced a fixed cost, the transport cost of 20 Rand to and from the depot. And we then focused on the effect that this had on our overall profit. We used a flow diagram to calculate the output values produced from several input values. Now let's look at the values that we got inside this table. Is there a pattern evident in this table? Well, let's have a look. As the input increases from 1 to 2, that's an increase of 1 unit. What is the increase in the output values? Well, we can see that the increase in the output values is 6,5. If the input value increases by another 1 unit, again the increase in the output value is 6,5. And for the last unit jump in the input value, again the output values change by 6,5. That's amazing. Even though this formula was different from the one we used in lesson 1, we still repeatedly add 6,5. Why is that so? What is the same between the formula we saw in lesson 1 and in lesson 2? Let's refer to the flow diagram to set up a formula. Our input value was firstly multiplied by 6,5, then we subtracted 20 to finally get our output value, or y. We can write this formula as y is equal to 6,5x minus 20. Now let's write both these equations down so that we can compare them. In the first lesson, we worked with y is equal to 6,5x. In the second lesson, we were working with profit, and the equation then was y is equal to 6,5x minus 20. Now, what do you see that is the same in the formulae? Well, in each formula, the coefficient of x, or the rate of change, is 6,5. Let's see how the same rate of change is shown on graphs. We're going to analyze the similarity between the graphs of y equals 6,5x and y equals 6,5x minus 20. Do you recall from grade 9 what shape these graphs should be? We're going to show them in this Cartesian plane over here. This is my first graph. There is the equation y equals 6,5x. Let's check that that is indeed the correct equation. When I put an input of 1, x equals 1, I can see that my output is 6,5. So indeed, y is equal to 6,5 multiplied by x. My second graph is given by the equation y is equal to 6,5x minus 20. Let's check that this one is correct. If I place an input of x equals 4, you can see that the output is y equal to 6. Now I know that 6,5 multiplied by 4 is 26, and if I subtract 20, I get my output as shown in the graph of 6. I hope that you expected both graphs to be straight lines. Remember that for both formulae, for each 1 unit of change in the input values, the difference between two consecutive output values was constantly 6,5. Now, if the difference between consecutive output values is a constant number, then the function is always linear and therefore the graph is a straight line. In both formulae, the coefficient of x is 6,5, and this is the rate of change. What effect does this rate of change have on the graphs? We'll analyze the lines. What is the same about them? Clearly, both lines slope up and to the right. Let's see how the output values change if the input value changes by 1. There I've increased my input value from 0 to 1. Let's have a look at the change in the output value. The output value was 0, it is now 6,5, therefore there is a total change of 6,5 in the output value for this graph. Let's have a look at the next graph. Again, I have made a change in the input value from 3 to 4, in other words, it has become 1 unit bigger. Now the output value changes from being minus 0,5 to being 6, which is again a total change of 6,5 units. Remember that we're using two formulae from the example when we sold aluminium cans. For both lines, when the input or x values increase by 1 unit, the output or y values increase by 6,5 units. Remember, this was exactly the same amount as we calculated in our tables previously. The rate of change is the same for the two formulae, therefore both graphs have the same gradient. In other words, they are parallel. Now, what is the difference between the lines? Well, to investigate this, let's zoom out so that we can see more of the Cartesian plane. Let's zoom out again. Right, here we can see that the graph of y equals 6,5x passes through the origin. In other words, when the input is 0, the output is 0. But what does this mean? Well, it means if I collect no cans, I'm not going to get paid anything. The second graph, y equals 6,5x minus 20, cuts the y-axis at minus 20. In other words, when my input is 0, my output is minus 20. Can you work out what this means? Remember, the 20 in the formulae for profit represents the amount that I need to pay for transport costs to and from the depot. So if I travel to the depot without any cans to sell, I still need to pay 20 Rand. In other words, I make a loss of 20 Rand. Let's now have a look at your task from the previous lesson. Now, as we've been working in rands throughout, we should convert 40 cents into rands. We know that 40 cents is equal to 0,40 Rand. And we know that our formula is input times 0,4 Rands in this case, minus our transport costs of 20 Rand equals the output. In other words, the formula we were working with was y equals 0,4x minus 20. Your task, remember, was to find out the mass, which gives an output or y value representing a profit. Now I'm going to go back to the monitor to show you this using a graph. Make sure though that you get the same result. The graph is also a straight line. For a profit, it means that the output value or y must be positive. And remember that y is positive where the line lies above the x-axis. And the straight line cuts the x-axis at 50. In other words, the output values are positive when x is greater than 50. This means that we need to sell more than 50 kilograms of steel cans. Did you get the same answer when you did this as a task? I also hope that while you were doing your flow diagrams, you remembered to estimate and predict. You should have seen that for small input values like 1, 2, or 3, the output values were negative, indicating a loss. On the graph, you can clearly see that for these input values, the output values are negative. Did the flow diagram take you a long time to do? I hope that you realized the pattern early on and so started to use larger and larger input values. Let's now see how much money we can make by comparing the amount of profit we can make by selling steel cans versus aluminium cans. And again, we're going to use the graphs to do this comparison. The pink line shows the graph of the profit made by selling aluminium cans. Compare these two lines. What is the same about them? Well, both lines cut the y-axis at -20. And in both formulae, remember -20 represents the transport costs to and from the depot. Look at what is different between the two lines. Clearly, the slopes of the two lines are different. The y values increase much more slowly for the green line than for the pink line. Remember what it is we are comparing. We're comparing the profit that we can make by the sale of different types of cans at different prices. The gradients of the lines are different because their rates of change are different. For the green line, the rate of change is 0,4. The pink line has a bigger rate of change, and hence it has a steeper gradient. Remember that the amount paid per kilogram of aluminium cans was 6.50 Rand. Hence it has this steeper slope. So it makes sense that if we receive more money per kilogram, we're going to make more profit. Let's see how that works again. For the pink line, y is positive when x is a little bit more than 3. In other words, I only need to sell 3 kilograms of aluminium cans to start making a profit. However, I need to sell more than 50 kilograms of steel cans in order to start making a profit. Let's summarize what we've learnt. In terms of selling a specific mass of cans, the more money we are paid per kilogram, the more profit we will make. In a linear formula, the coefficient of x is the rate of change. A linear formula has a constant rate of change. The bigger the rate of change, the quicker the y values or output values increase. I hope that you enjoyed this lesson and learning about the patterns formed when using formulae. Do join me for the next lesson called Precisely. Until I see you then, bye-bye.